It's July 17th. We're doing our Tuesday night tube guitar amplifier webinar session. And the first item in the queue tonight was sent in by Rick. Rick has the vintage place over there in California. He says, how about add a reverb kit for a Tweed 5E3? Now, we talked about this before because we have the kit that Ulrich had designed, and this is the board for it. It comes with a board and it's all silk screened, and all you do is look at the board, and then there's a bill of materials that you can identify what parts are what, Q1, Q2, blah, blah, blah. And it's paint by the numbers. You fill it in. And when you finish, the board is populated. And let's see here if I can find the pictures for it. Okay, I got them in a different folder. I know where they're at. No, I don't either. Oh man, I screwed that up. Let's see, how do you go back? Yeah, here they are. Here's one of them. This is a picture of the unit after it is installed. Now, it comes with a power supply. The little white box here, let me get my pointer out. This little box here, that's the power supply. Now, you can mount it anywhere. He just mounted it. This customer just mounted it on the back side of the chassis, since a 5E3 does not have a cap pan, so there's plenty of space. And then he mounted the board, and you can see he put these little nylon standoffs. He just popped them into the chassis, drilled a couple of holes, and popped it right in. And here's your RCA jacks that go to your reverb pan. And then there's a couple of hookups. You got your DC power hooking up to the board here. See, here's your DC supply, and it hooks up to the board there. You've got your in and an out, which is, I believe it's, I don't know if it's there, or it's one of these here. And then you got your reverb pan, which is here. And I don't know for sure what this is here. This is high voltage and ground, because some of these transistors are those transistors that act like a 12X7, and they're like, LND
150.
Yeah, it's a 300 volt deal. You hook it up like a 12X7. So anyway, that's the way it's all hooked up. And then when it's all done, I mean, this is the circuit right here. And it's got some little options on the board. These right here are not normally used if you're using it on a Tweed Deluxe, but if you're using it with other amps where there's no capacitor on the input, then you go ahead and add these components in there so that you can block DC. But other than that, it's pretty straightforward. So you hook up your 24 volt supply here, which we showed you, and you got your input here and the output over here, or here, depending on which one you're going to be using. So that's pretty much it, and that's how it's done. The thing that's nice about this kit is everything's been worked out for you. You don't have to think about anything. You just stuff the components in the board. You would use a wire across here if you're using it for a 5E3, because that goes directly to the input. And that's pretty much all there is to it. Okay, Nordstrom, go ahead. If for some reason you're not unmuting. There you go.
All right. Hey, if anybody needs any original Gibbs reverb pans from the 60s, I've got 30.
How cool is that? What impedance are they?
What?
What impedance are they?
I don't know. They're the 12. They're the standard ones that came in the Vibrolux and all the earlier tweeds from the mid 60s. I found a box of them in a warehouse. They're all new old stock. They're brand new. So
check the DCR on those inductors. If they're the right pans for a Fender,
Yep.
one inductor is going to be like a little bit over 1 ohm DCR,
Okay.
and I think the other one's going to be right around 200 ohms. But check those, man. If that works, if that's the right one, man, that is a great sounding pan. That's probably one of the best sounding reverb pans ever made.
Yeah, that's why I got them. I was. This guy asked me. He brings me all this weirdly weird stuff, and I got about 2,000 Switchcraft jacks and plugs too.
Oh wow. Well, I'll probably buy some of those from you. And I might be interested in a couple of those Gibbs pans for myself. You know, I had some Gibbs pans here, but the ones I had a master case of them. They came 25 to the master. The ones I had were for Ampeg, and they were the wrong impedance for the input. You know, because Ampeg is a capacitor input, so it's higher impedance. And back in the 90s, when in the first part of the 90s, when Accutronics went over to the new transducers they were making in-house that sounded crappy compared to their old ones, I called over there to complain about it, and they said, well, too bad, you know, this is what we're doing. And I said, well, do you have any of the old transducers left? And they said, yeah, we got maybe about 100 of them, 50 or 100 of them or something. I said, I'll take all the ones you got left. So I bought them, and they sat in my box here, you know, just a parts bin forever. And those Gibbs pans sat in that master carton forever. And then one day I got the idea, why don't I put the Accutronics transducer in the Gibbs pan, you know, for the input so the impedance would match. And I hooked that up, and man, I tell you, it was glorious. It was absolutely glorious. One of the best sounding reverb pans I ever heard. And I sold those pans. They were brand new. I sold them with the new transducers for 125 a pan, and they were gone in like 2-3 weeks. So, yeah, that's a great pan. How much you want for them? Wait, I must have unmuted you somehow. Maybe you muted yourself. How much you want?
Shoot.
How much you want for them, Nordstrom?
I think about $20. I'm trying to make some dinner for my kids, and
Yeah, I'll buy 3 of them from you.
all right, I'll contact you later.
Yeah, I'll buy 3 of them. I'll buy some of those jacks. I'll buy a couple of hundred of those Switchcraft jacks. Are they the kinds with the switch? Or are they just two
I've got a whole bunch of different ones right now. I've got the locking ones. I've got just the straight mono. I've got stereo, but I'll get you what I have.
Yeah, okay, good. Well, get with me. I'll buy some of that stuff from you. I'll use that. I like some of those Gibbs pans just for myself, for my personal reverbs, because those are just over the top, man. It's just a great. And you know, if you look at the pan, they got a little sticker on there. It says "Made in Janesville, Wisconsin, by beautiful women."
Mm-hmm.
And I don't know if any of y'all ever been to Janesville, Wisconsin, but I have, and they're not kidding, man. Their women in Janesville, Wisconsin, are beautiful. It's a Scandinavian settlement, and all the women there. God, man, I shouldn't say this on recording. They're beauties. They're beauties, man. Tall, green eyes, well endowed, gorgeous women. Okay, it looks like you're on a different planet. Jeff's got his hand up. Go ahead, Jeff.
I just wanted to see if I could get a couple of those pans from Nordstrom too.
Okay. Okay, well, I'll forward his email to you when he sends me the email, Jeff.
Okay, super. Thank you.
Very cool, very cool. All right. Yeah, it would be really cool if you had a 5E3 circuit, put this reverb circuit in there, and then use one of those Gibbs pans. Oh, my God. It'd be awesome. Okay, let's see here.
Me too, Gerald. It's Chris.
Chris, I tell you what, anybody that's interested in those pans, just send me an email, and I'll forward you his email. He's going to send me an email of what he's got for jacks and pans and all that stuff. Okay? So just send me an email, and I'll forward you his email. These kits right here, I can't remember how much we sell these damn things for. Let's see here. I might have the pricing sheet. Hell, I don't know how much we sell them for. I think I know the dealer price is 100, and it's I think it's 125 or 150 regular, and then 100 for the dealer price. You got to buy 3 to become a dealer, though, and then after that you can buy them onesie twosies. But we recommend selling them for 200. You know, if you're gonna put one in an amp, you can sell it for 200. People will go crazy over that. Get reverb added to their 5E3 for 200 bucks. That's a deal. All right, we're gonna move on. I had an amp that came in, and this amp was very unusual. I'd never seen one like it before. It's a little tiny. This thing's probably, man, it's probably 6 inches by 2 inches by 4 inches. The chassis is. And here's some pictures of it. Well, let me get some. These are some of the pictures. I tore it apart to take good pictures for the. I was trying to see if I had one of just the whole thing. Here it is right here. It's kind of an unusual design. The chassis is not really a whole chassis. It's just a piece of metal, and it's got a couple of bars across, and then the circuit board, which looks like some kind of bake light, is just screwed onto the back. Now I'd removed a screw right here, but that's how it was. You had a screw here and a screw there, and there was one over here, and you could take the screws out and this board would come off and you could access all the inside, but the whole thing was like super small. And the reason it came in was the guy had bought it and it didn't have a transformer in it. So he needed to know what he had to do to put a transformer in it. So he called me and asked me if I would do it, and I said yes. So I got the thing, and the first thing you need to do if you're going to put a transformer in is you got to decide what kind of transformer you need, and what kind of circuit it is, and what kind of voltages and current and that sort of thing. And I didn't have much to go on because I didn't have the old transformer. I researched it on the internet, couldn't find a schematic anywhere, and spent a lot of time looking for it. And so what do? You got an amp that doesn't have a transformer in it. You don't know if it's a half-wave rectifier, full-wave rectifier, or what. And you got to figure it out. So that's what I did. I had to figure it out. And we're going to draw a schematic of this here in a minute. Let's look at some of the other pictures. Yeah, this is what it looked like on the faceplate, and this is just like a little piece of, I don't know, it looked like something a little bit thicker than paper that was on there. This was a True Tone amp. You know, True Tone was an amp sold by Weston Auto back in the early 60s. Matter of fact, we used to get a Weston Auto catalog, and they'd have a little guitar in there for $39, and then the amp was, I think it was like $29 for the amp. And I used to sit there and look at that and obsess over it. It was guitar porn for me. But anyway, so I got the amp and I started looking at it. And, it's kind of a cool amp. These are all wire wound resistors here, and it uses disc caps. Only had a few of them in there. And they had see, I'd taken the board off to show you. It was an actual printed circuit board, but it had real nice wide traces on it. Real nice wide traces. And this is the transformer I put in it. And I couldn't find, nor did I have, a transformer that was a lay-down transformer. And see, the thing is when I researched it on the internet, I found out the amp itself was only 5 inch, the cabinet was only 5 inches deep. So that means this chassis from here, let me show you from where to where. From here to the furthest reach of this transformer had to be less than 5 inches. So it had to be a lay-down transformer. And, there's only a couple of different kinds of transformers you could put in there. You could put a half-wave rectifier, or you could put a full-wave rectifier or a full-wave bridge. So I looked real close to the circuit to see what they were doing on that circuit, And let me see if I can find the picture for it. I found they only had one diode in it, and the transformer, it just had one diode. So I assumed with one diode, what would that be? That wouldn't be a bridge, would it?
It'd be half wave.
It's got to be. It's got to be a half wave. So it's a half wave rectifier. And then I looked at the tubes, and the tubes I'm not really familiar with these tubes. I've seen them used in some other amps, but I didn't know all the specs on them. A 6AV6 and a 6AR5. Now, I looked up the pin outs for these, and what I did is I just take the pin outs and copy them using my snipping tool, and I pasted them into a drawing. So it's got two 6AV6s and one 6AR5. Well, when I looked them up, the AR5 is an output pentode. So this has got to be your output stage right here. Let's see if I can get this thing to type. This has got to be your output tube. And since there's only one, we know it's single-ended, right? And then these tubes here are just triodes. And so this has got to be your preamp tube. And you got two of them. Okay, now we know that the rectifier circuit only showed one diode, so we know it's a half-wave rectifier. And when I looked up the voltages on these tubes, they were running roughly somewhere around 300 volts, 250, 300 volts, roughly around there. So I surmised, think about this a minute, half-wave rectifier, you want to get 300 volts. What comes to mind? "6G15 Reverb" from Fender. Remember the standalone reverbs? Those were half-wave rectifier, and they put out 295 volts. So it's like right in the ballpark. So what I did is I got a transformer that retrofits to a 6G15 Fender Reverb, which is going to put out about 295 volts. And I used that. But now, when I wanted to figure out the circuit, I looked at it, and you could see, you know, when you want to draw out a schematic, what I do is I start off with the tubes, because you got the tubes, and you know that each tube is going to have a cathode circuit, a grid circuit, and a plate circuit. And then you're going to have a power supply as well. Well, I'm looking at the power supply, and I see, I'm going to draw this. I see it's got a two-prong plug. Let me get back to this thing is screwing up here. Okay. That's not supposed to be there. Okay, let's see here. Let's see if this is going to work now. Okay, there are two input jacks. And each input jack went to a 100K resistor, and they were connected together. And there was a 250K to ground. And then I also notice a capacitor going to pin 1 and a 5 meg to ground. So I drew my grid circuit. I just took a flashlight and looked on the circuit card, and it was written right on the resistors, you know what they were. These were 100Ks right here. both of them. Okay, and this was a .005 cap. Okay, now I can ignore the heater circuit. We can ignore this because we know that all amps are going to have a heater. So we're going to just ignore this heater circuit for right now. And all three of these tubes, the heater is 3 and 4. Okay. The input on this thing was a 2-prong plug. And you could see one of them was going to a fuse. And one was going to the back of the pot, which was a switch. So from that, I knew that these 2 wires here had to go to the primary of the transformer. And then there was a secondary on the transformer. And I knew one of these had to go to ground, and one had to go to the diode that was still in the amp, and it was connected to a 40 microfarad, I think it was a 40 microfarad capacitor. And then, of course, there was a heater circuit here that went to your filaments. So I knew that that would be the way to hook that up. But when I was messing with this, some of the wires were falling off. Anybody here ever had that happen? You got something that's real old?
Nah,
Yeah.
never ever.
Yeah, well, some of the wires were falling off, so I had to figure out where these wires went. And I didn't have an output transformer on this, because the output, see, here's the filter cap, 40, 40, and 20. And here's the way that that was configured. When I looked at it, let me get back to here. When I looked at it, this was 40. There was a 3K resistor here, and there was another 40 here. Now, you're probably wondering, why are they putting so much filtering on this little tiny amp?
Because it's single-ended.
Well, that's part of it, but there's another reason. See, this was going
Plus
to
it's
the...
half wave.
Okay, here's the reason. This is going to go... See, there was no output transformer. The output transformer is hooked to the speaker, and the guy didn't send me that. But, you know, there has to be an output transformer. So, and I called the guy and verified that it was on the speaker. And what I did is I used a Tweed Champ transformer to test this with. Because, why? Because a Tweed Champ transformer is about 8,200 ohms. And when I checked this in the tube manual, at 250 volts, it was recommended running it at 8,000 ohms. So 8,200 is close enough for me to test it. You know, when I'm going to ship it back, he's going to hook it to his transformer. But I needed to test it before it went out there, and he didn't want to ship me the cabinet and the speaker and all that. So I just hooked it up to a Tweed Champ transformer. So what I had to do is I had to find out which pin was the plate on here, because that was one of the wires that had broken off, was the plate wire. And this was 40 here. And then there was another resistor, and this is a 20 here. And you know what? I never did answer the question why they use such heavy filtering, because this is like a 3-watt amp. It's like, why do you need 40 and 40? There's a good reason why. And it's not just because it's single-ended. This is going to go to the plate circuits of these. You're going to have a plate circuit there. And let's see, where's the other plate circuit? There was one here. And these are 100K. It's interesting they used all wire wound resistors in here, which is something you never see, but it's kind of cool. It's like a mil-spec kind of thing. Here's why they use heavy filtering. On a half-wave rectifier, your ripple current is 60 hertz. 60 hertz is a lot harder to filter down to pure DC than 120 hertz. So what they did is they had a pi filter here, and this pi filter was before the output transformer. So all of the current from this output transformer is going through this 3K. Everything's going through that 3K. And they've got a screen resistor in there too. Let me see what the heck I've got right here in front of me. I have to take a flashlight to it. No, it's a 30K. Yeah, they're using a 30K. And the 30K is the screen. Where's your screen? Right. That's the suppressor. Here's the screen right here. $30K. And then there's another dropping resistor that's going to the front end. Let me see what the value is on that one.
I don't guess you'd get much screen current on that, would you?
No. No, not much at all. I'm looking. Yeah, you don't get much screen current. It looks like they've got 100K here, which, 100K is not going to drop much. These here are probably drawing altogether maybe 2 milliamps. So that would be a 200 volt drop. And man, that would be quite a bit of a drop. Maybe I've got that backwards. They might be using the 100K for the screen and 30 for the other. Not sure about that right now. I could check that later. But the important thing is to figure it all out. This right here had a little coupling cap, and once again it was a 0.005, and it was feeding a simple volume pot, and the wiper of that volume pot was going to the grid of the next stage, and the cap from this, which I think also was a 0.005. Let me look and double check that. Yep. They're all 0.005s. Every coupling cap in the amp is a 0.005. So 0.005. And then this is going to feed the grid of the next stage, which is 1, and there is a 250K pot going to ground. Not pot, 250K resistor. I said pot. Sometimes my mouth doesn't work. Okay, so that's the whole schematic right there. I mean, just by drawing the tubes out and then
That's a cool idea to just take and cut and paste those pictures of tubes. I like that idea.
Yeah, you just go on the internet and find the RCA data sheet, which like this one here, and then you just get your snipping tool and click new,
right,
and then you just copy that sucker, paste it, boom, and then fill in the blanks, the tube has got to have a cathode, a grid, and a plate circuit for it to work. So all you got to do is just draw that in once you get the tube in, and you kind of recognize these circuits. I read these sheets on here because I wasn't real familiar with this tube, and this tube is like a 6K6. It's almost the same performance-wise as a 6K6, but it's a miniature version. Well, 6K6 is like a smaller 6V6. So let's see what the plate watt dissipation. I think it's probably like 3 watts or something. Let's see if it's listed on here. Oh, they're saying it's 8.5 watts maximum. But I don't think this thing's running anywhere near 8.5 watts. 250 volts. Oh, and it had a cathode resistor on it. See, where's the cathode circuit? Right here, number 2. It did have a cathode resistor. And the cathode resistor, where's the cathode? Right there. It was 200 ohms. And it looked like a pretty high wattage one, too. I don't think it was bypass, though. Let me look again. I might be wrong. No. I'm looking to see. It's hard to see in this light. No, there's no bypass cap on it. So, it's a real spongy attack when you don't have a bypass cap because the bias keeps changing as more or less current goes through the tube. You hit it hard and the bias changes in favor of cutting off, cutting back, and then you hit it soft and there's not much bias voltage, and that's in favor of more volume. So it's like a built-in compressor kind of thing. Now here's the interesting thing. After I hooked this all up, there were 2 wires going to the board for the heaters, so I grounded one of them. And now we're going to do the brain teaser. I turn it on, and immediately is drawing crazy current. Immediately. I had it in a current limiter, and turn it on, boom, the light was bright. Okay. So now I want you to tell me, what would that be? You turn it on, the light's bright. What would that signal? Not you, Frank.
Oh, come on.
Think about it. Because you got to use your brain when you're troubleshooting this stuff. You got to think.
It means the power's on.
What's that?
It means the power's on.
Yeah. Yeah, the power definitely on, but there's also when I got the amp, it had a blown fuse too, and there was no transformer in it. So something was drawing current. But what would be the first thing you would look for? You turn it on, you put the transformer in, you're sure everything seems right, and you turn that sucker on, and immediately, boom, it's drawing a lot of current. Robin, go ahead.
It's a short somewhere.
Well, of course there's a short.
Yeah.
Okay, well, where would you look?
I'm looking.
In the amp.
In the amp, yeah, right.
I mean,
Well,
you tested the caps, right? I mean, the caps are good, the filter caps?
Well, I mean, I don't know if they were good or not. I just know
okay.
I turned the amp on and it was drawing a lot of current. So what do you do next?
I would make sure the caps are good. I don't know if you intentionally left out the cathodes on the preamp tube, but not that makes a difference.
Oh, no, they don't have a cathode on this. This one is grid
Grid
leak
leak
bias.
bias.
Yeah, that's grid leak bias. This one here does have one. And let me look on it and I'll tell you what it is. It's a 3K, and it's unbypassed also. It's a 3K unbypassed, so I guess they weren't big on using bypass caps, and they weren't big on using big value coupling caps either. Those .05s are going to, you know, be real trebly.
Yeah.
Yeah, this is a 3K.
Of course, it probably had a tiny little speaker in it too.
Oh yeah, you know, it's like I think it's a little 8-inch. The thing's supposed to put out 3 watts, you know. Okay, so I turned it on. The thing's drawing current immediately. So the first thing I did is I thought, well, maybe that output tube is shorted, because if the output tube was shorted, maybe, you know, filament to plate or something, it could be that, you know, that's what blew up the transformer and blew the fuse. So I pulled out all the tubes. That was the first thing I did. I pulled out the tubes, and that rules out that there's a shorted tube, because I didn't know if those tubes were good or not. The guy sent me the tubes. I don't have a way to test a 6AR5, you know. So I pulled them out, plugged it back in to the current limiter, turned the amp on. The light was bright. The light was bright, so there's
I have
short.
a Hickok. I have a Hickok 800A tube tester. I'll sell you real cheap.
Well, it does. You know, it doesn't matter. The point is the tubes were out,
Right.
and the thing's drawing current. So you wouldn't think, and it might even be that one of those tubes is shorted, but that ain't what was causing the short I was seeing, because it was shorted with the tubes out. So if it's shorted with the tubes out and it's instant, what else could it be?
I would say
Transformer?
he just put a new transformer in it.
Put a brand new transformer in it. Yeah.
I would suspect either that diode or one of the filter caps being shorted.
Yeah,
That's what I would suspect.
That's it. Yeah.
Well, that's what I suspected too. And so what I did is I cut this. I took a pair of wire cutters and I cut that wire going to that diode, because that rules out the diode and the filter caps, right? You cut this, they're not even in the circuit. So I turned it on, and lo and behold, it's drawing current like a bitch. Not as much. It's not drawing as much current, but it's still drawing a lot of current, way more current than it should. The light was pretty bright.
New transformer.
Mm-hmm.
You got one end grounded. Wow. Where the hell is the current coming from?
Yeah, that's what I was thinking.
Did you
Okay,
check
Jeff's got his hand up. Let Jeff get his word in here.
The volume pot slash power switch.
Yes.
Volume pop power switch. Nah, that wasn't it though. All that was just a switch to turn the thing off and on. You know, when you turn it off, when you turn it off, it didn't draw current. When you turned it on, it did draw current. So I don't.
Is there a pilot light in this thing?
Yeah, and you know, I didn't show the pilot light, but it's in parallel with the.
I know, that's why. Since you got all the tubes out, I thought the pilot light would be the next thing. You know, the 6.3 volts can draw quite a bit of current too.
Mm-hmm. Yeah, but that wasn't it.
Okay.
Let me tell you what it was. You know, when I put this transformer in, I knew this was single-ended amp, right? So one side of this filament had to be grounded, right?
Right.
So that's exactly what I did. I grounded it. Damn it, this is the wrong tool. Let's get it where I can show a ground. I grounded one side, and then of course this went to the filaments and the pilot lamps and, you know, all of that stuff. Okay. What it was is further down, upon inspecting the circuit board, this side here was already grounded on the board.
Oh, man.
And so with that grounded on the board, it shorted this 6.3 volt out. And God, it's a good thing I had it in the current limiter, because if I would have turned that off, I mean, if I'd have turned it on without a current limiter, it would have smoked that brand new transformer.
Yep.
It would have smoked it.
I never turn anything on without a current limiter.
Me neither.
Yeah. Yep.
Me neither. In fact, matter of fact, I've got one that we made years ago. It's got a switch on it that shorts out the light bulb.
That's how mine made too.
Yeah, and then that way I don't have to keep unplugging, plugging. You know, I just plug it in. I got it marked, you know, which way is limit. I always put it on limit, always. And I can't tell you how many times that saved me from burning something up. You know, and then if it's drawing too much current and the thing's showing a bright light, you can actually work on the thing even though it's drawing a lot of current, because that light is limiting the current, and it's limited to the point where there's not enough current in there to blow anything up. And so that's kind of cool too, because you can go through and start troubleshooting stuff, cutting wires and different stuff that you think might be drawing current. When you cut the one that's drawing the current, that's going to be, you know, an easy way to troubleshoot stuff, because the light will go out. Now on this one, there wasn't really that much that could possibly short. Once I cut the diode wire here, this wire, I cut that wire going to the diode. You only had one end of this going to the chassis, so the only thing that left was this filament. And I started looking at that. I said, it's got to be that filament. There's nothing else that's connected to the circuit. That, you know, that both wires are connected to the circuit, unless it was a defective transformer. It was a brand new transformer. I didn't suspect that. And then, you know, I got my reader glasses on, and my magnifying glass, and my flashlight, and I looked real close at that filament circuit on the board. And sure enough, man, they had a trace. And this goes to prove my 50-50-90 rule. Now, see, I had a 50-50 chance of getting this right. If I would have grounded the other one, the thing would have worked, and I would have never even noticed it had two grounds. So I had a 50-50 shot at getting it right. But the 50-50-90 rule is such that if there's a 50-50 chance of you getting it right, it's a 90% chance you'll get it wrong. And I can support that with lots of evidence. Just look at any Fender amp that comes in. Look at the filament polarity of the output tubes. And they're almost always wrong. Almost always. I don't think I've ever gotten a twin in here that they had it right on all four tubes. Never. And they're almost always wrong. And that's something you can do that's real easy fix. Just swap some wires, and it'll do wonders for making the amp have less hum.
That's one of the things I've learned on this webinar.
I check every amp that comes in for that, because
I do now too.
I mean, it's just a standard deal, you know. It was something that they made mistakes on repeatedly because they weren't paying attention to that.
When I build an amp, I use different colored wires for each side. That way
Me too. Makes it easy to check it. And, you know, another way that's easy to check it if you can't see it very well is you can just take a meter and turn the amp on, and take a meter and put 1 meter lead, put it on the voltmeter setting, AC, and put 1 meter lead on, say, pin 9 of or not pin 9, because we're not going to do it on preamp tubes, pin 2 of an output tube. Let's say you're doing a 6L6, a pair of 6L6s. You put 1 meter lead on pin 2, put the other meter lead on pin 2 of the other tube. If it's 0 volts, they're in phase. You know, the polarity is correct. If there's 6.3 volts there, then they're backwards. So that's an easy way to check without having to strain your eyes to see if it's twisted right, or, you know, does that wire go, is that going around there or not? I can't really tell. You don't have to worry about that. You just do it with a meter, and you can instantly find it. So let's say you had a twin, you know, and you got 4 tubes there, and the filaments are 2 and 7 on each tube. Just take a alligator clip it onto pin 2 of 1 tube, and then just go down and clip that to one end of your meter. And then take the other lead from your meter and just go pin 2 of the next tube, pin 2 of the next tube, pin 2 of the next tube. And any ones that are backwards, switch them. Switch them. So anyway, so that's my little project amp. And I wanted to share that with you because I wanted to show you the thought processes going through this. You know, you get something, you got to use your head. You got to think about it, you know. I mean, I knew that this used these tubes. I researched the tubes, found out they like to operate around 300 volts, you know, and I noticed it was a half-wave rectifier. So, you know, I asked myself, what transformer do I know of that would work for this? And it just seemed to be perfect for the 6 G15 Fender Reverb, standalone reverb. And also that standalone reverb used a 6K6. And when I was researching this 6AR5, it said similar parameters to a 6K6. So all of a sudden, 6K6, half-wave rectifier, 300 volts. It all points to that that reverb transformer.
How did it sound after you got it done?
Like a 3-watt amp that was real compressed and had a lot of high end.
All right.
And really that's what it's designed to do.
I understand.
Yep, that's what it's designed to do.
Ever figure out what blew the original transformer?
Who knows? Who knows? It could have been anything. I mean, you know, maybe they had a voltage surge. Maybe it was just old and you know, been overheated before. I don't know. You know, sometimes transformers don't last forever. This thing was made probably in the early 60s, probably about 65. You know, so what does that make it? 60 years old or something? Or something like that. 65, let's see, it'd be 35 years to the turn of the century and then another 18 years. So 40, 53 years old. Yeah, you know, stuff doesn't last forever. Lee's got his hand up. Let me call on Lee. I'm going to unmute you, Lee. Go for it.
Unmute you, Lee?
Hey, Gerald.
Yeah, man.
Hey, everyone. Would you, a couple things. I need to start having a notepad with me.
You don't need a notepad. You can go on the internet and use your username and password and view the webinars. I usually convert them to a WMP file right after we finish and upload it. Usually by midnight, it's up there.
Yeah, I know that. I'm just talking about when we're live like this. Well, first of all, you talked about the filament power to the tubes on this. You know, where you got 2 tubes. What difference does it make if it's polarity correct or not?
Hum.
In terms of, is it hum?
Yeah. Well, what we're talking about is it matters on a push-pull output stage. Now, this one is a single-ended output stage, so it's not an issue here about polarity because you don't have hum cancellation available. But if it was a push-pull amp, let me see if I can find one here real quick. Push-pull amp. I'll pull one up here in a second. Let's see. Okay, here's a push-pull amp here. Let's use this. What is this? No, that's not it. That's not it. Damn it. Here's one.
I've got my twin reverb right now on my bench, and I'm gonna do some stuff to it, and that's one thing I'm gonna verify.
Yeah. Okay. This is here's a push-pull amp. I just pulled one up out of my folder there. But see, here's a push-pull amp. Okay. So you've got one tube is feeding one side of the transformer here, and the other tube's feeding the other side. Now, let's say that you hook them up and they're in polarity. You know, in other words, pin 2 goes to pin 2 and pin 7 goes to pin 7. Then you're going to introduce the same exact amount of hum here as you do here. But since they're going into opposite ends of the transformer, they're going to phase cancel each other, and you won't have any hum.
Right.
Now, let's say you did it the other way, where they were reverse polarity. And this 2 was connected to 7, and 7 was connected to 2. Well, then you would have one phase of hum going in here, and you'd have the other phase of hum going in here, and then when they would end up over here, they would double. Instead of canceling, they would double. And so now you got four times as much hum, because instead of halving, you're doubling. So that's almost, you know, it's 2 square. So that's why that's important. And that's something that nobody paid attention to back in the 50s and 60s. They hooked it up, and however which way it was, that's the way it was. And some amps just hum more than others.
We're talking about the filament, so the 6.3 volt filament. Right?
Absolutely, yeah. The part
right. You're just using this as an example. I got you.
Yeah, I'm using this example to show you that on a push-pull output stage where you have two output tubes.
Right.
They're going to phase cancel each other. The hum is going to phase cancel each other if you hook them up in the correct polarity. And that's what you want, because you don't want a bunch of hum.
Right. Cool. The second question was, I pulled up on the 6AV6 tube, and 2 of the pins, 5 and 6, are for diode number 2 plate, diode number 1 plate.
Yeah, they don't use that for that. It's just they've got them all hooked together to to ground. They just hook it to ground.
Right. Okay.
Yeah, they're not using that. They're using the triode function only.
So if they were using those, there'd be you go to a diode plate or whatever in the circuit.
Well, I don't know. I've never seen anybody use those. I mean, Fender used a similar tube, that 6 AT6 on the Harvard. And I don't think they connected it to anything. Let me see if I've got that one here. Oh, let's see. What is the number of the Harvard? No, that's the Tremolux. There's the Harvard right there. Yeah, see, they don't even show it on the schematic.
Oh, they got it. Yeah, I got you.
Mm-hmm. Yeah, you don't use that. And that 6AV6 has about the same gain as a 12AT7. You know, it's roughly, but you know, the 6AV6 or the 6AT6, see, those are not humbucking filaments. Your 12-volt tubes are superior because a 12-volt tube it's got a 12.6 volt filament, but it's center tapped. And so what you do is you take the 2 ends and hook them together, and that counts as one lead, and then the center tap counts as the other. So really you're running 2 6.3 volts in opposite polarity, which makes it hum canceling. It's a 12.6 volt tube, but since you're cutting the filament in half and you're wiring them in 2 separate halves, then it's really 2 6.3 volt filaments that are reverse polarity. Think of it that way.
Why did they use a 6AT6 in Harvard like that?
I don't know.
Okay. Thank you.
Probably because they just needed one triode there.
Yeah.
It's probably because Leo had 500 of them on the shelf.
Yeah, but I think it's more what Frank said about they just needed one triode. See, the way we would do it nowadays, if we were going to build this amp, I would build it with all 12X7s, and I would just have half of a 12X7 not being used.
Either that or double it.
Yeah, or you could even double it, and that's a good way to do it too. But back then they weren't thinking that way. The way we think now, it's like, well, we want to always be able to get the tubes we need. So we're going to design around 12AX7s because you can get a 12AX7 anywhere. It's a great sounding tube. It's got plenty of gain. If there's a place anywhere that sells tubes, they're going to sell a 12AX7. It's the most popular tube on the planet. So we would just put a 12AX7 in there and either, like Frank said, either double it, which sounds real good, or just have a half that you're not using.
I got you.
Mm-hmm.
But just double that same circuit right there, then the 6AT6. Just parallel that.
Well, yeah, but when you parallel it, there's some things you got to do.
Okay, right, I got you.
You got to cut this in half.
Right.
You got to cut this in half. You got to double this, and you got to half this.
Right.
In order to make it work right, because when you've got two halves, your plate resistance, you cut that in half, but you got twice as much current going through this cathode here. So in order to maintain this correct bias voltage, you need to cut this one in half. But when you cut this one in half, now you've changed the ratio of capacitive reactance of this capacitor. And so in order to compensate for that, you've got to double this one.
Mm-hmm.
Double this one and half that one when you double the tube. And then, of course, half your plate resistor.
You also have to double the voltage on that capacitor? Or just the...
What voltage? There's no voltage on the capacitor.
Well, 2525. I thought they were rated...
No, that's not... That capacitor does not create any voltage.
No, I know that. But they have a voltage rating on them.
Oh, they're using a 25 at 25 on just about everything. It doesn't have to be a 20. I mean, it needs to be a 50. If you're going to change this to half,
in order
for this to have the same frequency response, this one has to be doubled. And when you double it, it just needs to be 50 microfarads. Now, you could probably use a 6-volt cap in there and it'd work just fine. You'd have plenty of safety area. But, Fender just used 25/25s on just about everything.
Right. Got it.
Yeah, it doesn't hurt to go over on the voltage. The voltage rating is not what it has to have. It's just what it will stand before it breaks down.
Right.
This customer of mine brought over an amp the other day, and he'd bought some, I think they were I remember the brand, but the 25s the double 25 at 25, it was huge. I mean, it was as big as the circuit board almost.
Well, it probably wasn't an electrolytic.
No, it was an electrolytic. It was a what's F&T, I think, is what it was.
And it was a 25 at 25, and it was huge.
Yeah, but it was a double 25 at 25.
Oh, a double.
But it was so big it wouldn't hardly fit on the circuit board.
Well, when I get those doubles, I just take two singles, tie the grounds together, and count that as one, and just mount it where it works perfect.
That's what I do too, but
it looks good too.
Yep.
All right, that's about everything I got for tonight. Anybody got anything they want to talk about before we shut her down? Let's see. Anybody's hands up? Nobody's hands up. Boy, we got an attentive crowd tonight. We had 25 people on tonight.
Anybody new tonight? I sent a friend of mine an invitation. I forwarded him that email that you sent out.
Cool, man.
You got any new people tonight?
I don't see any new people on here.
Okay.
Let's see. I see all the old regulars though. They're all on here.
I'll have to scold him.
Well, you know what? I got a guy.